Okay, another Calculus 3 tutorial. Today we are going to see how to find the curvature of this vector function at t is equal to 1. And because we are given a vector function, so it's easier if we use the following formula for the curvature. Kappa is equal to, we will need to get the first derivative of r, and we do the cross product with its second derivative, and then take the magnitude of it, and then divide it by the magnitude of the first derivative of r, and then raise that to the third power. And of course, we have to plug in t is equal to 1 and all that. So let's just go ahead and get to work. Look at this and take the first derivative. R prime of t is just going to be 1, 2t, 3t squared. And because we care about when t is equal to 1, so you really don't have to work with the variable version. You can just plug in 1 and then work it out later on. So r prime of 1. This right here will give us 1, 2, 3, which is much easier. And then let's go ahead and get the second derivative. So look at this and take the derivative. We get 0, 2, 6t. Okay, and then we will plug in 1. So we get 0, 2, and then 6. And now we have all the ingredients. Perhaps let's go ahead and do the cross product next. I am going to write it down right here. R prime cross R double prime. I'm just going to do the cross product this and that. So this right here is going to be, okay, I, J, K, and then 1, 2, 3, and then 0, 2, 6. Okay, perhaps we will do the shortcut. I'm just going to do I, 1, 0, and then J, 2, 2. All right, so the shortcut works like this. I will do this times this times this, which is 12i, and then we add this times that, but that will be 0. So next, we do this times this times this, so that will be 2k. And now we go the other way, but it will be a subtract. So this times this will be 6j, and then subtract again. This times this, that will be 6i. And lastly, this times this, that will be 0. And we can combine this and that together. So this and that, when you do the cross product, we get positive 6i, and then minus 6j, and then we add 2k. Now, we will have to do the magnitude of this thing. So here we go. The magnitude of R prime cross R double prime. This is just going to be, we open the square root, and then we square this. We add, square that, which is negative 6. And then we add that, which is 2 squared. Okay, so if you work this out, 36 plus 36 plus 36 is going to be 36 plus 36 plus 4 is going to be 76. This is square root of 76. And then you can simplify it. You can factor out the 4 times 19. So square root of 4 times square root of 19. So that would be 2 square root of 19 for the cross product for that. Okay, then let's go ahead and do the bottom part, which is this thing's magnitude. And perhaps I'll just do it right here just to save some space. Right, magnitude right here. So that will be square root of 1 squared plus 2 squared plus 3 squared. Yeah, something like this. All right, so that's 1 plus 4, 5 plus that is 14. Yes. So, ladies and gentlemen, here, the curvature kappa, right, at t is equal to 1, is just going to be this divided by square root of 14. So 2 square root of 19 over square root of 14. Oh, I'm sorry to say, this thing has to be raised to the third power. So take this raised to the third power. And what this means is, you have 2 of this times 1 more, right? So it's like square root of 14 squared times square root of 14. But that's just 14. So we can look at this as 2 square root of 19 over 14 times square root of 14, and then reduce this and that. So, ladies and gentlemen, 1 over 7, and perhaps I'll put them together, square root of 19 over 14. Pretty fun one. That's it.